All right, welcome to the 10th of 10 types of lab math problems, which is serial dilutions. Here we go. This is your first practice problem. Your supervisor provides you with a 6.0 milligram per milliliter bovine serum albumin solution and asks you to make a 5-step, twofold serial dilution, in parentheses, 2 to the negative 1 at each step. After you perform the 5-step, twofold serial dilution as requested, what is the dilution factor at the final step? So, here we go. First thing we have to figure out metacognitively, is it a solution or a dilution? Well, because it is saying step and fold, and it's asking us for the dilution factor at the final step. Now, this is going to be important. That means this is a serial. Well, it means it's a dilution. And as for the type, if it's talking about step and fold, and it wants the dilution factor at the final step, because it's mentioning step again, then it is a serial dilution. Now, this is going to be slightly adapted because how you solve these, the equation for these is actually that you draw out basically what you do at the bench. So the equation is we're going to draw it out. To do that, we need to find our variables, which is the step and the fold. The step, as they say, is 5. The fold is 2. So, what the step is, this is the number of containers or the number of dilutions you're going to be making from your stock solution. So you start by always drawing a container. I'm just kind of drawing a general test tube. You could make this in any type of container. I'm just drawing this because it's simple. And you label that as your stock solution. Now in this, our stock solution has a concentration of 6 milligrams per milliliters. Cool. We just need to know that that's the stock. Now I'm going to do 5 steps, which means I'm going to make 5 dilutions from that stock. So I draw out 5 containers plus the stock. In other words, you draw out the number of containers that matches the step plus 1 because you need that extra 1 for the stock. Now in a serial dilution, you take the stock and you make your first dilution. Then you take that step and you make your second step. Then you make your third step, your fourth step, and because they've told us we're making a 5-step, this is our 5th and final step. This is really the dilution that we care about because that's where we're stopping. These other ones were just steps to get to what we actually wanted. Usually, sometimes you want all of them. All right, so I've drawn it out. There's my 5, right? So that's my 5. Check, taken care of my step. Next, I'm going to go in and I'm going to put the dilution factor set up under all of my steps. All the dilution factors will start with a 1 and then the ratio sign. The reason being, this amount that you transfer from each step is the exact same amount. So for example, if you took 10 milliliters of the stock to make step 1, then you'll take 10 milliliters of step 1 to make 2, 10 milliliters of step 2 to make step 3, 10 milliliters of step 3 to make step 4, 10 milliliters of step 4 to make step 5. And since it's the same amount, that means it can always be simplified down to a 1. So you can just preset all of these as 1 in, 1 in, 1 in, 1 in. Then the final thing we do for step 4 is we plug in our fold. So that's 2. Well, that just means that's our first number there. 1 in 2. All right? Then we move on to step 5, which is convert. Because we are dealing with dilution factors, there is no conversion. Then we get to step 6, which is solve. All right? Now to solve, that means I need to finish filling in these additional dilution factors. So how I do that is I take the first fold, which is 2, and I multiply it by the fold. Again, the fold is 2. So I take this y, because remember these are set up as x and y, that's y1, x in y2, x in y3, x in y4, x in y5, and then I multiply 2 by the fold, which gives me 4. Well, that is now my y2. Now to get y3, I take y2 and I multiply it by the fold. So I take that 4 and I multiply it by 2. So that's now 1 in 8. To get y4, I will take y3, which is the 8, and I will multiply that by the fold, which is 2. So that gives me 16. Then to get y5, I take y4, multiply it by the fold again, and that gives me 32. A lot of students like to use exponents. Technically, exponents should work on this. However, I will say I have a lot of students who don't use them correctly and therefore get the wrong answer. So only use exponents if you are incredibly confident in your exponent calculator game to do it right. Otherwise, just do it 4th grade style and take the previous y, multiply it by the fold to get your next y. All right, so we have done step 6, we have solved. Now step 7, we're going to reread the problem for what they want. We can see that they've asked, what is the dilution factor at the final step, step 5? Well, this is step 5. 1 in 32 is the dilution factor. That is the answer. Bada bing, bada boom. I don't know why I said that. That was weird. All right, now let's look at the other type of serial dilution problem you can do. I'm trying to get these paired up side by side, so hopefully you can see your supervisor provides you with a 6 milligram per milliliter bovine serum albumin solution and asks you to make a 5-step 2-fold serial dilution 2 to the negative 1 at each step. After you perform the 5-step serial fold dilution as requested, what is the concentration at the final step? These are the exact same problem except for what they are asking you to solve for. The one we just solved for asked for what is the dilution factor at the final step. This one asks what is the concentration at the final step. You would do for this problem, the second problem, because the variables are the same, you would do all of those steps that we just did exactly the same until you get to step 7. So here are our steps 1 through 6 that we did because it's all the same variables, the 5-step 2-fold. And now we're going to do a different step 7. So for step 7, we need to reread. We've got it solved out. They want what is the concentration at the final step. Well, remember the final step is this one right here, step 5, and they want the concentration. This requires just one extra pretty easy step. We take the final step's dilution factor, which is 1 in 32. We divide that, so 1 divided by 32 in parentheses, and then we multiply it by the original concentration of the stock. When we come back to the solution, we see our supervisor provided us with a 6 milligram per milliliter bovine serum albumin solution. That's what we made all of these dilutions from, so that is our stock. So we will multiply the final dilution factor by the original stock concentration. So 1 divided by 32 gives me that number times the 6, and that gives me 0.1875. And then what's the unit? Well, it's just the unit that the concentration was originally in, milligrams per milliliter. So that's our final concentration. Now, this problem didn't ask us to go to a certain number of decimals. If it was something like this, they probably would. So let's pretend for a second that they wanted us to go to 2 decimals. Then actually the final answer would be 0.19, because that's 12 milligrams per milliliter. And that's as simple as that. Now, let's say that the concentration that they gave this to us in was not 6 milligrams per milliliters. Let's say that it was 50% bovine serum albumin. You would still, and they still want to know the concentration at the final step. Well, the final step is this 1 in 32. So we would still do the 1 divided by 32, but then we have to multiply it by the percent. Remember, if it's a percent, you've got to convert that to a decimal. So that would be 1 divided by 32 times 0.5, which would give us this. But then I have to convert this back to a percent, so I've got to move it over 2 places. So the final answer, if it was given to us in percent, would be 1.5625%. And that's how you would solve if it asked for the concentration at the final step. Now, let's talk about problems to beware of. Please beware of finding the dilution factor that just looks like a serial dilution. Now, here's what I mean. Your supervisor provides you with a 1 milligram per milliliter solution of BSA and asks you to make a 5-step twofold serial dilution, 2 to the negative 1 at each step. If you stopped reading there and stopped thinking there, you're like, I got it. This is a serial dilution. Let me draw out my serial dilution. But this is why it's important to read and fully think. Because it then says, what is the dilution ratio if you add 100 microliters of that 1 milligram per milliliter BSA to 400 microliters of diluent? This is not actually asking you to do this serial dilution. It's asking you what's the dilution ratio if you add 100 microliters of what your supervisor gave you to 400 microliters of diluent. That means this is a dilution, but it's not a serial dilution. It's a find the dilution factor, meaning you don't have to draw it out. You would use the equation of stock in stock plus diluent, and then simplify. So please look out for those. And that's it, guys. That's how you do serial dilution problems.